Hello class, welcome to this video on 4.3 practice. This is the practice questions from Canvas. So let's go ahead and get started. This is all about triangles. This was SAS and SSS. So for each triangle, determine if they are congruent based off of the theorems or whether you cannot determine. So here we have a side corresponding to a side corresponding to this side, and then this side corresponds to this side. So you should be putting SSS for this example. For the second problem, we have a side corresponding to a side. We have an angle corresponding to an angle. And then we have bireflexive property. This side corresponds to the same side. And so this is going to be SAS. Right, so here we have a side corresponding to this side, a right angle corresponding to this right angle, and then we have a side corresponding to the same side by the reflexive property. So this is going to be SAS. And then for this next set of triangles, we got a side corresponding to a side here. We have an angle corresponding to an angle. And then we have a side not corresponding to a side that would normally be on the other side. So if you look at this, this is actually a side angle, and this is a side angle side. And so this right here does not correspond to this according to the diagram. So and so in this case, we cannot determine this. Okay, so we can't determine based off of SAS or SSS or anything like that. So all right, so this one here, we got this side corresponds to this side corresponds to this side, and then by reflexive property, this side corresponds to itself. And so both triangles are SSS, and so this is SSS congruence criteria. We have a side corresponding to a side, angle corresponding to this angle. And so, but notice that even though these angles are the same, the sides do not correspond. So this side does not correspond to this side because this side would normally be, well, let's look at it this way. So this side corresponds to this side. Or would actually, this side would actually correspond more to, yeah, so this side would more correspond to here, but notice that the angles are not in the same position compared to the side. Okay, so yeah, so this is clearly not correct. So therefore, this angle should actually be more here. And so it's wrongly placed according to, according to if we wanted to use a congruence criteria. And so this can't be determined, or I'm not entirely sure. I don't remember what the option menu says, but it's not one of those options. So these cannot be determined or not congruent. All right, so the second question, what additional information is needed in order to know the triangles are congruent with the given method? So we got a side angle side. For this first triangle, or set of triangles, we have this side corresponds to this side, so that makes sense, okay? And so we got a side. Now, technically, we have an angle here because we know that these two angles are vertical angles, and therefore they have to be congruent. And so we do have an angle here. So we have a side, we have an angle corresponding to the same angle on the other triangle. And then what we're going to need is this side right here. We need to know this side. We need to know that these are congruent to get SAS. And so therefore we know that JI, this side, has to be congruent to EI. We have to know that. Okay, so the answer is D. For triangle 2, we already know that we had this side is congruent to this side. This side is congruent to this side, and so we're going to need another side. So we need to know that RT is congruent to ZX. Okay, so we have RT is congruent to XZ. Okay, for triangle 3, We have a side and a side. So these two sides correspond. That makes sense. And then we need an angle. So, and then we technically have a side here because this side is congruent to itself. So we have a side and a side. We need an angle, and more specifically, we need this angle. We need to know that angle, and so that's angle EFS. We need to know that angle EFG. I mean EFG is congruent to angle QFG. Okay, so that's this one right here. Triangle 4, we have this side is congruent to this side. We have that bireflexive property of congruence, that this side that they share is congruent to itself, and so that counts as a side. And then so we need another side, right? So we need to know that this third side is congruent to that third side. So dx is congruent to yz. Right, question 3, write the missing reason to complete the proof. So we have proof here. We have two triangles. It says here that we're given that AB is congruent to CD. So we know that this part right here is congruent to this part right here. We know that angle A, is congruent to angle D. And we know that AF is congruent to DE. All right, and so we want to prove that the two triangles are congruent. And so remember, at this point, we cannot prove that we cannot say that these two triangles are congruent by SAS, even though it looks like it, right? Because we don't have this entire side. We need AC to be congruent to BD. So once we show that AC is congruent to BD, so essentially what I'm saying is once I show that this is congruent to this, then we can claim SAS. But until then, we cannot determine this. So we're going to go through the proof, and so that we can figure it out, so that we can make that conclusion. And so it says AF is congruent to DE. These are all given. Okay, so because line segment AB is congruent to line segment CD by the definition of congruent segments, that means that they're equal to each other. And so if you go to statement 5, if I know that these are equal to each other, right? Well, then I can add anything to it. And in this case, notice that we added BC on both sides. And so that's basically what I did. We add BC to both sides. When you add the same number to both sides, that's known as the addition property. So this is actually an addition property of equality. All right, and so that's what we did for step 5, the reason for that. And then once we did the addition property, we basically, using the segment addition postulate, we know that AC is congruent to, or AC is equal to BD right here. So how did I get that? Well, okay, so if you look at statement 5, and I'll color code this here. So this side right here, if you look at that, I'll erase these markings here so that we can kind of show you. We know that AB plus BC is AC because we know that this part AB plus this part BC has to equal this whole thing, AC. And then so that's how we got AC from that side. And then similarly, CD plus BC is BD, right? And so that's how we got this part. And so that's the segment addition postulate that we were referring to. Okay, so those are going to be clearly equal to each other by a segment addition. And then AC is congruent to BD because of the definition of congruence. and then the triangles are congruent. Why are the triangles congruent? Well, now we can claim SAS because we got a side, got an angle, and a side. And the proof is done. So I just want to kind of explain the reasoning for each of the proofs, just in case you have a different blank that you need to fill out on a test or something like that. So you definitely want to know the reasoning for each of the statements here. All right, question 4, show that the two triangles are congruent using deductive reasoning. So here, well, first off, we know that we know this side and we know this side and we know an angle, right? But so we know this, but we can't show triangles are congruent by ASS here, right? Or SSA. So we need some more information, but we know that these two angles are congruent because they're vertical angles. Okay, so we know that BCA is congruent due to the vertical angles theorem. We also know that we can get this angle right here, ABC, because if we know BAC, so if we know this angle and then we know this angle, then we can add them together and then subtract it from 180, right? So if we knew that this was 10, this is 20, then to get that, we'd have to do 180 minus 10 minus 20, which is going to be 150. So we can get this using the triangle angle sum theorem. Okay, similarly, we can get this angle with the same reasoning. And so if we were to get that, then we can go ahead and use some of our theorems here. Some of our theorems here. So clearly, if you look at this, it's going to be S, A, and then S. So we got the SAS here, and we got the SAS here. And so we know that by SAS, they have to be congruent. All right, so let's look at the next one. So given that triangle ABC is congruent to XYZ, use a rigid motion to prove the corresponding parts of congruent triangles are congruent theorem. This is known as the CPCTC. That's what we shorten that to. So define a set of rigid motions that map one triangle to the next. So all right, so basically, okay, let's look at the options here. If we were to reflect triangle ABC across BC, then translate it to the right and up, is that going to give us triangle XYZ? Well, so if we're going to reflect this across BC, so this is BC right here. If we reflect it, well then this guy is going to go to the other side right here. And so we'll have something like this. Okay, so that's how it looks like reflected. And then if I move it to the right and up, well, then that's not going to overlap with this triangle, right? So that clearly cannot be it. So it's not A. All right, let's look at the next one. Rotate the triangle ABC 180 degrees about A. Then translate to the right and up. So this is A. We're going to rotate it 180 degrees. So we're going to rotate this 180. So this right here, this point C is going to be rotated 180 degrees. But it has the same distance, right? It has the same length. And so that's going to be my new point C. We'll call it C prime. And then this B is going to be rotated 180 degrees in the opposite direction with the same length. And so that'll be like B prime. And then, so now we can draw our triangle. So we know our triangle is going to look like this. Okay. So that's how it looks like rotated 180 degrees. And then we translate to the right and up. And then if you look at that, is that going to work out? And the answer is yes, this is going to work out. It looks exactly like this triangle, and then we move it to the right and up, and it'll overlap. Okay, so clearly the answer is B, but I'll show you C and D just so that you can kind of convince yourself that B is the right answer and not the other ones. So reflect triangle ABC across AC. So AC is here, we're reflecting it across AC. And so this is going to go on the other side here. This is going to be reflected on the other side here. And these are going to stay, obviously. Oops, that's the wrong. I didn't mean to do that. So this is going to be reflected here. And so we have something that looks like this. Okay, it's a mirror image on the other side. And then if clearly that doesn't line up, because we shifted to the right, it's not going to line up. So it's not C. And then if we rotate about point C, so we're going to take this, point A, we're going to rotate it 180 degrees, about C, and we get this. Then we take point B, rotate it 180 degrees, so that's going to be like here. And so we have a triangle that looks like this. And then once we rotate it, then if we translate to the right and up, we clearly are not going to get them to line up. And so the answer has to be B. All right, guys, that is it for the practice. I hope you learned something from this video. And as usual, I'll see you in the next one.